All right. We're going to do some more of the homework. I'm going to put all these on Moodle. All right, let's go to 2342. For each of the following, write the UPAC name. All right, so before we write the UPAC name, you would, on the test, it would say circle the functional group, give the class of compound, and then give the name. So circling the functional group are easy points. You just circle that and you get a point. The double bond, then if you know that's an alkene, you get another point. And then to name it is worth 2 points or maybe 3. But definitely get the easy questions right. Circle the functional group and give the class of compound. All right, so then you have to follow the rules of naming, which is always longest carbon chain. And you want, in this case, for the alkene, the lowest number for that double bond. And so if you number it 1, 2, 3, 4, 5, 6, that's going to be the right answer, but you should go all the ways to make sure. 1, 2, 3, 4, 5, 6. All right, so it's 6 that way or the other way, and it's a 3 for the start of the double bond. What about these two down here? What if we did 1, 2, 3, 4, 5, and 6? Again, 6 is the longest carbon chain. And so you have a hexane, except you realize that you have a hexene, or you have an alkene, so it is not hexane, it is hexene. And the start of the double bond is at carbon number 3. So if we go the original way, which is this way, all right, any way you go is going to give you the same answer, as long as you put the 3 for the hexene. All right, so then you also see that 3 starts a double bond, but 3 also has a group. And you have to know that that is an ethyl. 3 dash between a number and a letter, ethyl dash 3 hexadyl. All right. Now you can also see that's an alkene, and it could be a cis and a trans. All right, this one is neither cis or trans because on the left side here, if we look at this carbon of the double bond, it has a CH2CH3. It has another CH2CH3. These are the same, and therefore no cis trans. Anytime you are naming an alkene, if it is cis or trans, it has to be included with the name. All right, for the second one, there you go. Oh, this one is interesting. So CH3, CH2, and then a C, double bond, CH2, and then CH2, CH2, CH3. So here is one where you're not going to find the longest carbon chain, because the rule is when you see that you have a double bond and that's another alkene, the rule is you get the longest carbon chain that contains the carbon-carbon double bond. So straight across is the longest carbon chain, but that doesn't include the carbon-carbon double bond. All right, and then you always want the lowest number possible for the carbon-carbon double bond, and so you start at the end closest to the double bond. So 1, 2, 3, 4, 5 is the longest carbon chain, which includes the carbon-carbon double bond. So that is a pentene, and the start of the double bond is on carbon number 1, so that is a 1 pentene, and then you see off of carbon 2, you have an ethyl group. All right, so it is not always find the longest carbon chain. It is find the longest carbon chain that contains the functional group. All right, that was 42, 44. Write the condensed structure formula for each of the following: 2,3-dimethyl 2-hexene, 1, 2, 3, 4, 5, 6 is a hexane off of carbon 2. I'm going to have a double bond, and a 2,3-dimethyl. All right, so I always write it as a line and stick model. All right, but that is not a condensed structural formula. But I can see here that since this carbon of the double bond contains a methyl and another methyl, there's no cis-trans for this alkene. And so when you would write these two methyls, you would write CH3 sub 2, then that's connected to a C with no H's, and then that's connected to a C. Again, this C has no H's. All right, and so your longest carbon chain is going to go, well, we wrote it from the name, it's going to go here. So this CH3 has to be in parentheses because that's connected to that carbon. And then you go with the longest carbon chain. You keep going, CH2, CH2, CH3. So both ways are difficult, going from the condensed structure formula into the structural formula, or going from the structural, or going from the name into a condensed structural formula. All right, so the next one is a 3-decene. So now we're writing 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. Off of carbon number 2, I have a methyl. Off of carbon number 4, 1, 2, 3, 4, I have a propyl, which is a 3-carbon group. And off of carbon number 1, 2, and 3, I have a double bond. All right, now this one, since this one has different groups on both sides, because there's an H here, and then, of course, that's a carbon group, not the same as H. Here's a 3-carbon group, which is different than a 1, 2, 3, 4, 5, 6-carbon group. So yes to cis-trans. And when you get to organic, the only ones that are going to be called cis and trans are the ones that have hydrogens on the same side or hydrogens on opposite sides. This would have a different naming system, which is a E and a Z naming system, but we're not going to do that in here. All right, but it says to give this in its condensed structural formula. All right, and so you have your CH3, you have another CH3. All right, so it would start as a CH3 sub 2 and then a CH. This one has an H. This one has an H, CH. This carbon does not have any H's, so that's just a C. But in parentheses, you put the propyl group, CH2, CH2, CH3, and then you keep going on the chain. CH2, 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 CH2. That's a lot of CH2s. You have 1, 2, 3, 4, 5. So I would write CH2 sub 5 and then finally a CH3. You could write it out 5 times CH2, or you can put the CH2 sub 5. All right, about 46, 23.46. Give the UPAC name and include the cis and trans label for each isomer. All right, and so when you look at the CH3 and then a CH, double bond, CH, and then CH3, you see that on this carbon of the double bond, it has a methyl and a hydrogen. Those are different. And this carbon of the double bond has a hydrogen and a methyl. Those are different. And so, yes, we have cis and trans. And since the problem says name it as a cis and trans, that is what we're going to do. So, of course, for cis, you can put them both on the same side. Doesn't matter if they are both up or if they're both down, but they will be in the same side. And so this is your cis 2-butene. All right, and then this is correctly named as cis because they are hydrogens that are on the same side. So the only way that you should call it cis trans is if it's hydrogen. All right, and so hydrogen, up, down, methyl. So they're on opposite sides, and now you have a trans 2-butene. And these are geometric isomers. They are stereoisomers. Right, 2348. Write the UPAC name for the following hydrocarbons. Hydrocarbon just means it's only going to contain hydrogen and carbon. So that's your alkanes, your alkenes, your alkynes, your cycloalkanes, your cycloalkenes, and your cycloalkynes, and also your aromatic hydrocarbons. All right, so this one has CH3, CH, then a C triple bonded to CH, and then down here, we have a CH3. All right, so again, on the test, you're going to circle this because that's the functional group, and you're going to say that's an alkyne. All right, and so then it's going to say, then name it. All right, so you got to find the longest carbon chain, but it has to have the lowest number for the triple bond. So the triple bond has to be in the longest chain and the lowest numbers possible. So you always start at the side nearest the triple bond. All right, and so 4 is the longest carbon chain, whether you go straight across or if you go down, doesn't matter, it's still 4. All right, so 4 is a butane, but we've already said that we have an alkyne, so this is not a butane, it is a butyne. And the lowest number, all right, so the carbon that starts the triple bond, the lowest number is then 1 for the butyne. Then off of carbon number 3, you see you have a methyl. So 3 methyl, 1 butyne. All right, so only the alkenes and cycloalkanes, but I don't think we're not gonna do any cycloalkane cis trans. So alkene cis trans is what we're going to stick with. Alkynes do not have any cis and trans isomers. All right, the next one is CH3, then a carbon triple bonded to carbon, and then a CH2 and a CH3. All right, so again, longest carbon chain, you have to start at the end closest to the triple bond. So in this time, it's from left to right. 1, 2, 3, 4, and 5. 5 is a pentane, except we have a triple bond. We know that's an alkyne. And so that is a pentyne. And then the lowest number for the start of the triple bond, that is a 2, pentyne. 2350. Write the structural formula for a 1,2,4 trimethyl benzene. All right, so you have to know what benzene is, or you would never get this right. So you have to know that benzene is a 6-membered ring, and it's alternating single and double bonds. Normally, we will write a circle in the middle, or alternating single and double bonds. All right, so then we have to put a 1,2,4 trimethyl. And so here is a 1,2,4 trimethyl benzene. For the next one, it says ortho diethyl benzene. So again, you have to know what benzene is. And you also, so you would write your benzene, do not forget to put the circle or the alternating single and double bonds, because then it's not benzene, then it's cyclohexane. Diethylbenzene, ortho. So you have to know ortho, which is O. You have to know that meta, which is M, and para, which is P. Ortho is a 1,2, meta is a 1,3, para is a 1,4. You have to know that, because otherwise you would never get this problem right. If you don't know that O is ortho and that means 1,2, you cannot get it right. So you got an ethyl group here and an ethyl group here. So that is an ortho diethyl benzene. 2352. Circle and name the functional group in each of the compound. And all right, so we got the first one here. So there's definitely going to be problems like this. You're going to have a compound given. Sometimes it's given in its condensed structural formula. And you would have to, this would be given as CH3COOH. You would have to know the only way to get 4 bonds is to have it as a carboxylic acid. So you have to recognize the functional groups for all of your different classes of compounds. So that's carboxylic acid. All right. But on the test, you're going to circle the functional group. You're going to give the classic compound. You're also going to name that compound. So 1, 2, that is an ethane. But for a carboxylic acid, you drop the E, you add oic acid. So that is ethanoic acid for the name. Of course, that one could also be the common name, because very few people will call that ethanoic acid, and that is acetic acid. But if it says to name it, either one would be a correct name. If it says the IUPAC name, especially on a multiple choice, all right, then you have to give ethanoic acid. If it says common name, then it wants acetic acid. All right. If it doesn't say, or if it's not multiple choice, I would accept either answer. Even if it says UPAC name and you give the common name, I would accept that. Unfortunately, a multiple choice, when both names are listed and it's asked for the UPAC name, then that's the only correct answer. All right, so UPAC means you're following rules, the rules of naming. Common name is just something that you memorize. You memorize that is acetic acid. All right, acetic acid doesn't help you name the next one, so, or any of the others. You don't follow the rules of longest carbon chain. So that is when you're doing a systematic naming. That is the International Union of Pure and Applied Chemistry rules. That's the UPAC name. All right, the second one here, part B, we've got CH3, CH, CH3, and then again, we have another carboxylic acid. All right, so again, you got a carboxylic acid. So you circle the functional group, carboxylic acid. Then when you go to number it, when you do carboxylic acid, same as your aldehydes, the C double bond O is always carbon number 1. That's where you must start. So you're not necessarily getting the longest carbon chain. You're getting the longest carbon chain starting at the carboxylic acid carbon. So 1, 2, and 3. So that is a propane. But we're dropping the E and we're adding oic acid, because that's how you name a carboxylic acid. So that is propanoic acid. All right, and then off of carbon number 2, you got a methyl. So you have a 2-methyl propanoic acid. All right, so for part C, it has HO, CH2, CH, CH3, and CH3. All right, so you circle your OH. You know that's an alcohol. All right, whenever you have alcohols, it's going to say label them as primary, secondary, or tertiary. All right, so you have to recognize that you have an OH connected to a CH2. All right, so an OH carbon with a CH2. That means it's connected to one other carbon. So that is primary. You have to be able to distinguish a primary, secondary, and tertiary alcohol. All right, longest carbon chain must include the carbon with the OH, and you want the lowest number possible for that carbon. So in this case, that is going to be a 1, 2, and 3. So again, we have propane, but we've already said we have an alcohol. For alcohols, you drop the E, you add OL. So that is propanol. All right, lowest number possible for that. For the carbon with the OH, that is a 1. So this is a 1 propanol. Off of carbon 2, you have a methyl group, 2 methyl. 1 propanol. Part D, you have an O double bond C, and then CH3, and then down here you've got a CH, and a CH3, and a CH3. All right, so here is your functional group. All right, so that is a ketone. All right, and so when you name a ketone, you drop the E, and you add ONE. So you have to find the longest carbon chain, lowest number for the C double bond O. So you always start the numbering from the carbon closest to the C double bond O, which is this one. 1, 2, 3, 4. All right, so that is a butane. But we know it's a ketone, so we are dropping the E of butane and we're adding ONE, butanone. All right, and the lowest number possible for that C double bond O is a 2. So this is a 2, butanone. Off of carbon 3, you have a methyl. So 3 methyl, 2 butanone. That's 52, 54. Write the UPAC name for the following. You've got HO and then CH2, CH, CH2, CH3, and then off of this one, you've got a CH2, CH2, CH3. All right, so this one is a very commonly missed question because, well, one, you circle the OH, you've got an alcohol. So we know we're going to drop the E and we're going to add OL. We're going to get the longest carbon chain, lowest number possible for the carbon with the OH. So that is a 1, and most people will just go straight across 1, 2, and 3, and 4. All right, but that's not the longest carbon chain because you have 1, 2, but then down here, this could be 3, and then 4, and then 5, and 5 is a longer carbon chain than 4. All right, so you have to go the longest carbon chain. Nothing says you go right to left, left to right. You go any direction where you have the longest continuous chain of carbons with the lowest number for the carbon that contains the OH. All right, and so in this case, that is a pentane. But again, we have an alcohol, so we know with an alcohol, we drop the E and we add OL. So it's not pentane. We drop the E and add OL. It's pentanol. We have to give the number for the lowest, for the carbon containing the OH, and it has to be the lowest number possible. In this case, that is a 1. And then we see off of carbon 2, we have an ethyl group. So we have a 2 ethyl, 1 propanol. And again, when you have an alcohol, you will be asked to label it as primary, secondary, or tertiary. So again, we have an OH connected to a CH2, which means it's connected to one other carbon. This one is a primary alcohol. All right, in part B, we've got HO and then CH2, another CH2, another CH2, and then a CH, a CH3, and a CH3 going down here. All right, so this one, we're back to the straight across is going to be the correct answer. Lowest number for the carbon with the OH, that's a 1 again. All right, so whether you go here and it's 5 or down here and it's 5, 5 is the longest carbon chain. And so again, you've got a pentanol and it's a 1-pentanol. So this is another 1-pentanol. But this time you have a methyl group coming off of number 4. So this is a 4-methyl 1-pentanol. Part C, we got CH3, CH, CH2, CH3. And then down here we've got a C. Not sure why they're showing the H bonding. Okay, there's an H. They don't usually show that, but all right, they are showing it here, and I will bring up maybe why they're showing it that way. We didn't really cover chiral carbons. If there are questions on chiral carbons, that would be extra credit. So a chiral carbon is a carbon that has 4 different groups. So if your carbon has 4 different groups, it is called chiral. So usually when there's a chiral carbon question, many times they will show the bond to H. And so that you see that this carbon has a bond to H, an OH, a CH3, and then a sec-butyl group. So this, and you put a little star by it, indicates that you have a chiral carbon. All right. However, the carbon right here is also a chiral carbon, and they didn't show that carbon-hydrogen bond separate either. But this carbon up here, you have a methyl, you have an ethyl, you have a hydrogen, and then you have a carbon with an OH and a CH3. All 4 of those are different. The only time you can have a chiral carbon, you only have to look at, if you're looking for chiral carbons, a CH or a C. If you've got CH2, well, you can't have 4 different groups because H is the same as H. CH3, of course, you can't have 4 different groups because you have 3 of the same, 3 H's. So when you're looking for a chiral carbon, a carbon connected to 4 different groups, you're only looking at the carbon that has 1 H or the carbon that has no H's. In this case, there's 2 carbons that have 1 H. You looked at both of them, and they happen to both be chiral carbons. All right, so we're naming it. Again, we circle the OH. We have an alcohol. We know that we're going to drop the E. We're going to add OL. All right, so our alcohol, lowest number possible for this OH. So we got a 1, 2, a 3, a 4, and a 5. If we went this way, it was only 4. All right, lowest number possible. So we always are going to start numbering from the end closest to the OH. Again, we have a pentanol. But this time, the lowest number for the carbon with the OH is a 2. We have a 2-pentanol. And off of carbon number 3, we have a methyl, 3-methyl, 2-pentanol. All right. Now we always will label our alcohols primary, secondary, tertiary. And maybe that's why they showed the H. All right. So this carbon here that has the OH, you've got 1 H and you've got 2 carbons attached to that, and that makes it a secondary alcohol. So anytime you have a CH2, it's going to be primary. Every time you have a CH, it's going to be secondary. Every time you have a C with no H's on it connect to the OH, you have tertiary. All right. Part D. And so we're back to an alcohol connected to a CH2. All right, so now we know that's primary. So this is a primary alcohol. All right, that's CH2. Now we have a CH. And down here is a CH3. And CH2, CH3. All right, so here's one where it's set up to get it right because you just go straight across. 1, 2, 3, 4 is the longest carbon chain. Lowest number for the OH is 1. So you've got your butane, but you know it's an alcohol, so we know we're going to drop the E. We're going to add OL, so this is butanol. Lowest number for the carbon with the OH is a 1. We have a 1 butanol. And off of carbon number 2, we have a methyl. We have a 2-methyl 1-butanol. All right, 56. Classify each of the following as primary, secondary, tertiary. Okay, so we're going to do the same thing that we did here, except they're telling us it's an alcohol, but we're going to also name it. So we have CH3, a C, a CH3, CH3, CH2, CH, CH3, and OH. All right, so anytime you have a CH, it's secondary. So if you got a CH2OH, doesn't matter what else it's attached to, it's primary. If you've got a CH, doesn't matter what else it's attached to, you've got a secondary. If you've got a C with no H, so it's just all carbon groups, then you've got tertiary. So this is a very simple question. If the question is just primary, secondary, tertiary, CH, it's a secondary alcohol. All right, but let's name it. Longest carbon chain, lowest number for the carbon with the OH. So we have to number it starting here so that the lowest number is here at 2 for this carbon with the OH, then 3, and then 4, and then 5. All right, so we have an alcohol. We drop the E, we add OL. 5, we have a pentanol. We give the lowest number for the carbon with the OH. That is a 2. Then we see off of carbon number 4, we have a methyl here and here. So we have a 4, 4 dimethyl 2-pentanol. So you can't just say dimethyl 2-pentanol because the other methyl could be wherever. All right, you be very specific. It is a 4 and a 4. Both methyls are on carbon number 4. All right, 56. The next one here we got CH3, CH2, CH2, and then we got a C with the CH3 up, OH to the right, and CH3 down. Again, we have a carbon with no hydrogens. That is tertiary. So we have a tertiary alcohol. That means that carbon is connected to 3 other carbons. So to name it, longest carbon chain, lowest number for the OH. Again, we have a pentanol. The carbon that is connected to the OH is a 2. So we have a 2-pentanol. Also off of carbon 2, we have a methyl. So we have a 2-methyl. 2-pentanol. Every time you have a number and a letter, you have a dash. All right, the next one. CH3, CH2, and then a C, CH3 down here, CH3 to the right, and then a CH2OH up here. All right, so you see you have a CH2OH. That's a primary alcohol. Anytime the C with the OH has 2 hydrogens, it will have 1 carbon. It is a primary alcohol. Longest carbon chain, lowest number for the carbon with the OH. That is a 1, 2, and then 3 and 4. So now we have a butane, but it's an alcohol, and so we know to drop the E of butane and add OL. We have a butanol. We put the number for the carbon with the OH. That is a 1. We have a 1-butanol. Off of carbon number 2, we have a methyl and we have another methyl. Again, you have to write the 2 twice. 2, 2 dash dimethyl. 1-butanol. And then part D, we got a CH3, CH2, and then a C, and then down here, CH2, CH3. Then up here, we got a CH2, CH3, and then here we have the OH. All right, so we have a carbon with the OH with no hydrogens. That is tertiary. All 3 of those bonds are to carbon. So we have tertiary alcohol. This one is extremely symmetrical. You cannot number this one wrong. Well, you could if you didn't give the longest carbon chain. If you find the longest carbon chain, any direction is the same longest carbon chain. And that is 1, 2, 3, 4, 5. Any way you number the 5, you can go down here, left, right, up, down. 3 is the smallest number you can get for the carbon. Every way you do it, it's a 3. And so we have a 3-pentanol. All right, and so then also off of carbon 3, we have an ethyl group. All right, so longest carbon chain, lowest number for the OH. The reason why some people will miss it is they'll put a 1 for the OH. No, OH is not always number 1. The only one that's always number 1 is a carboxylic acid or an aldehyde. Everything else, longest carbon chain, lowest number for the functional group. All right, 58. What is the common name of the following compounds? All right, so now we're doing the ethers, and we'll do both names for our ethers. It specifically asks for the common name. And there's a reason why, because you have to have your groups memorized. All right, so this one, if it says give the common name, you have to give the common name, because I'm not really testing if you can name this ether. The test is, do you know, and I do know you know this because every other name has it in it. I know you know this is methyl. All right, but this is what the test is about. Do you know what this group is called? All right, so you have to know that this is a butyl group because there are 4 carbons. All right, and so when you have 4 carbon groups, there are 4 of them. All right, so there's 4 carbon groups. Yes, there's 4 carbons and there's 4 of them. You got your N-butyl, you got your sec-butyl, you got your isobutyl, and you got your T-butyl. And when a common name is asked, that is going to be the question. Do you know what those look like? All right, you need to know those. Those are very, very common groups. All right, and this one is your T-butyl. Now, the order you put this one in is not going to be any points taken off if it's not done correctly, because in a common name, you actually use the T as alphabetical order, but in a di, and a tri, and a tetra, you do not. All right, so this one should be a methyl T-butyl or tert-butyl or tertiary butyl and ether. All right, now ways to remember this, since we just did those. If I did N-butyl alcohol, so that's 4 carbon group, CH2, CH3, CH2, CH2, CH2. All right, so normal just means a straight line butyl. If I add N-butyl alcohol, I'd put the OH here. No one ever has a problem with the regular butyl straight line group. All right, so note that every N, any normal butyl, pentyl, hexyl, whatever, it's always going to be primary because it always has a CH2 and then an OH. All right, but specifically for the butyl, the sec butyl is the only way to get a alcohol here in this position. And so you look at this, and we just did it. You have a CH, so you know that this is a secondary alcohol. So that is a primary alcohol. This is a secondary alcohol, and that's how it got its name. That's why it's called a secondary butyl group, because when you put an alcohol on there, it is a secondary alcohol. Isos always have an ending or a beginning, depending on how you want to look at it, of 2 CH3s. And then here you have a total of 4 carbons. All right, and so your isos, every iso is going to be primary except for the very first one. When you look at your butyl group, all right, so to have a butyl group, butyl has 4 carbons. Your isopropyl has 3 carbons. And so the only way you can get 2CH3 with 3 carbons is this way. And this is the only iso group that will have a CH. Every other iso group is going to have a CH2, because to get to the next one, you just add a CH2. You keep adding CH2s to get to the next iso. So if you wanted isooctyl, well, then you would have to have a total of 8 carbons. So there's 4. You would need 4 more CH2s. So the way you would do it is CH3, CH, CH3. And so if you wanted the isooctyl, you would have to have a total of 8 carbons. Here's 3. You would need 5 more. And then an OH if you wanted to have isooctyl alcohol. All right. So, your every iso is primary except for the isopropyl. And so here, I already told you that this is your T-butyl. But if we made this an alcohol instead of an ether, you see that that alcohol has a carbon that has no hydrogens on it. And this would be a tertiary alcohol. And so this butyl group would lead to a tertiary alcohol. And so they call that a tertiary butyl group. So if you draw a blank and you remember a primary, secondary, tertiary, you should be able to come up with all 4 of your butyl groups. All right, the next one is 2 benzene rings. Oh, and I didn't do that either. So here is an ether, which is in the name. So you have an O connected to 2 carbons. You circle the O as the functional group, and that is an ether. Same thing here. We're going to have 2 benzene rings. So this one, you would have 2 functional groups, because you have your aromatic hydrocarbon anytime you have a benzene, you have an aromatic hydrocarbon, and then you have an ether. All right, so this one again is, did you memorize this alkyl group? All right, so you have to have benzene, you have to know what that is. Then you also know that when you take an H off of benzene, all right, so that's what we did. We took one of the H's off, and now we connected it to a group. So when we subtract an H, you have to know that that is called, so that means you're going to have a group coming off here, a phenyl group. So this is a diphenyl ether. All right, so when you're naming your ethers, many times it's going to say give the common name. And the question there is not necessarily naming of the ether, is do you know the names of your alkyl groups that you have to have memorized? (2360). All right, UPAC name for the following. We've got CH3, CH, CH3, and then you got, again, everything was going so well. All right. And then you have a CH, Got your CHO. All right. So there's only one way that you can have a CHO have 4 bonds to carbon, 2 bonds to oxygen, 1 bond to hydrogen. There is only one way to do that. All right. So you have to be able to go from CHO to a C bonded to an H. Open another window. And then bonded to an O. But in order to get that to be 4 bonds, it has to be a C double bond O and an H. All right, so you have an aldehyde. So this is your functional group, and that is an aldehyde. All right, when you name an aldehyde, you are going to drop the E, and you're going to add Al. All right, so longest carbon chain, but with the aldehyde, you must start with the C double bond O as carbon number 1. So 1, 2, doesn't matter which way you go here. 3 is your longest carbon chain. All right, so that would be a propane. But we're going to drop the E and add Al. That is a propanal. All right, and then off of carbon 2, you've got a methyl. So you got 2 methyl. Propanal. Just erasing everything. All right, let's see. All right, the next one is CH3, CH, CH3. Then down here we have a COCH3. Again, you have to write 4 bonds to every single carbon. If there's not 4 bonds to every carbon, you have the wrong answer. All right, so many people will not put 4 bonds to carbon. They'll just put a bond here and a bond here and call that an ether. No, this carbon only has 2 bonds if you do it that way. Every carbon must have 4 bonds. Every hydrogen must have 1 bond. Every oxygen must have 2 bonds. And there is only one way to do that when you're given a condensed structural formula. So you have to see that this, all right, all those carbons have 4 bonds. You should see that. You should also see that this one, in order for it to have 4 bonds, it can't be a single bond to O and a single bond to C. That would only be 2. That means that it has to have a double bond to O, and then it's connected to the CH3. That is the only way to give all of the carbons 4 bonds and every oxygen 2 and every hydrogen 1. All right, and so then you circle the functional group. This is a ketone. When we name it, we're going to drop the E. We're going to add ONE. Lowest number for that C double bond O, so we're going to number it closest to that end. 1, 2, 3, and 4. That would be a butane. We're going to drop the E and add ONE. We have butanone, the lowest number for the C double bond O. That is a 2, butanone. Off of carbon 3, you have a methyl. So you have 3 methyl. 2, butanone. Part C. You have CH3, CH2. Down here, you got CH2. This one, they write out the structure for you. So this one is much easier because they don't put it as CHO. They put it as the bonds all shown. All right, so again, you have an aldehyde. That means we're going to drop the E. We're going to add Al when we name it. All right, again, it's the longest carbon chain. However, your C double bond OH aldehyde, along with the carboxylic acid, that carbon is always carbon number 1. So 4 is the longest carbon chain, so that is a butane. But we're going to drop the E of the butane and add Al. That is butanal. You never put the 1 in front because all aldehydes are 1. All right, then part D, we've got CH3, CH, CH3. This one comes down to CH2, and then a C double bond O. So in this one, they give us another ketone, but they actually, instead of writing it as that CO, they actually write it for the 4 bonds to carbon. All right, and so that is a ketone. So again, we're going to drop the E, and we're going to add ONE. Longest carbon chain, lowest number for the C double bond O. All right, and so we're going to start at the end closest to the C double bond O, and that is this end. 1, 2, 3, 4, 5, and it doesn't matter which way you go. You can go this way for 6 or that way for 6. It makes no difference. 6 is the longest carbon chain, so that would be a hexane, except we've recognized it to be a ketone, so we're going to drop the E and we're going to add ONE. So this is hexanone. The number where the C double bond O is a 3. So this is a 3-hexanone. Off of carbon 5, we have a methyl. So we have a 5-methyl. 3-hexanone. All right, 62. Identify each of the following compounds as primary, secondary, tertiary, amine, or an amide. All right, so we have a C double bond O, we have an NH2, and we have a benzene ring. All right, so for this one, we would circle the C double bond O NH2. When they are connected, a C double bond O is connected to a CH2. You have to know that that is the functional group for an amide. All right. Your NH2, anytime you have an NH2, that means that nitrogen always has 3 bonds. That means that the other bond is bonded to a carbon. All right, and so anytime you have an NH2, you're going to have a primary amide. So NH2, anytime you have that, that's always primary. If you have an NH, that is always secondary. And if you have an N with no H's, that is tertiary. So that is the similarity between the alcohols and the amines, is that when you have a CH2 connected to your oxygen, when you have a CH2 connected to your, it's primary. If the CH connected to the OH, it's secondary. And if there's no H's on the C connected to the OH, it's tertiary. So amines are different, but they do have a similarity. All right, but on the amines, it's all about what's connected to the nitrogen. Whereas the alcohols, it's not what's connected to the O, because the O is always OH. It is the carbon that is connected to the OH is what you're looking at. All right, if we want to name it, longest carbon chain, is 1. This is a group. And so that would be a methane. To name an amide, you're going to drop the E. You're going to add amide. So this is a methanamide. So it would be methane, 1 carbon. We drop the E. We add amide, methanamide. All right. You don't have to put 1, but you can. So the 1 is not required. And you have to know the name of this group. So that is a 1-phenyl, or simply phenyl methanamide. All right, here we have CH3, CH2, CH2, NH2. All right, so again, you have an NH2. When you have an NH2, it's primary. If you had an NH, it'd be secondary. If you had N with no H's, it's tertiary, except this is not an amide because there's not a C double bond O connected to this NH2. It is an amine. So this is a primary amine. All right, so we can name this 2 ways. You can see that you have an N-propyl. Propyl would be fine. I usually put the N. Amine. So if you just said propylamine, that would be fine. I am very clear that it's not the isopropyl group. It is the N-propyl group. So I would call it N-propylamine, or longest carbon chain. All right, you have to have the lowest number possible for the carbon connected to the nitrogen. And you're going to drop the E, and you're going to add amine. So that is propane. But we're going to drop the E and add amine. So that is propanamine. All right, and then you have to give the number for the nitrogen, lowest number possible. So this is a 1-propanamine, because if you would put it here, longest carbon chain is still 3, so it is still a propanamine, but now it's coming off of carbon 2. So this would be a 2-propanamine. All right, so you give the lowest number possible for the nitrogen. Uh, 2363. Give the UPAC name for the following. So we have CH3, CH, CH2, and then COOH. And then down here we have a CH3. All right, so first you're going to write out the structural formula, not the condensed structural formula. You have to write out the structural formula. All right, so you've got your CH3, CH, CH2, CH3. All right, so that is showing 4 bonds to all of those carbons. This one is not showing 4 bonds to that carbon. If you do this, that is 2 bonds to that carbon. That is not the structure. If you don't have 4 bonds to carbon, you have the wrong structure. All right, so one of these oxygens has to be a double bond to O, and then the other one is an OH, and now you can recognize that as a carboxylic acid. All right, and so when you name a carboxylic acid, remember you're going to drop the E, you're going to add oic acid. So you got to find the longest carbon chain. The C double bond O is always carbon number 1. 4 is your longest carbon chain, so that would be butane. But you're going to drop the E and you're going to add oic acid. So you have butanoic acid. And you see that off of carbon 3, you have a methyl. So that is a 3-methyl butanoic acid. All right, the next one is CH3 connected to CH, connected to CH2. This CH has a CH3. The CH2 is then connected to a carbon double bond carbon. And off of this one, we got an H. And here we have an H. And here we have a CH3. All right, so we have an alkene. So you see that you have an alkene. All right, so the name is going to end in ENE and not ANE. It's an alkene. Longest carbon chain contains the C double bond C. You have to have the lowest number possible, so you start at the end closest to the double bond, and that is this end. 1, 2, 3, 4, 5, and 6. So you have a hexene. And you give the lowest number for the start of the double bond, and that is a 2. So carbon 2 is the start of the double bond. That is a 2-hexene. Off of carbon 5, you have a methyl. 5-methyl-2-hexene. Many people will stop at that answer and going to lose some points because this is an alkene. And alkenes have cis-trans isomers that are possible. And so this one was written that this hydrogen and this hydrogen are on opposite sides, which is a trans. And so you have to write trans 5-methyl-2-hexene. All right, so the next one has a CH3. Get your CH. And down here you got CH2, CH3. And then you've got your C double bond O and CH2. And then a CH, CH3 up and CH3 down. All right, so you have your functional group. You circle it. You have a ketone. You know that you're going to drop the E. You're going to add ONE to name your ketone. You need the longest carbon chain and the lowest number for the C double bond O. All right, so you start at the end closest to the C double bond O. Again, if you go straight across, this is going to be the wrong answer. You need the longest continuous carbon chain. And so you can go 1, 2, 3, 4, 5, 6, 7. Or you can go 1, 2, 3, 4, 5, 6, 7. And it doesn't matter, you think, because the lowest number possible for the C double bond O is a 4. All right, so 7 is a heptane. But we know it is a ketone, so we're dropping the E and we're adding ONE. So we have a heptanone. And we have a 4-heptanone. It doesn't matter which way you go, and it's still a 4-heptanone. But it does matter which way you go in this one, because you have other groups coming off. If there were no other groups coming off, then it wouldn't matter. All right, but you got a methyl here, and you have a methyl here. And whichever one gives you the lowest number, that's the way you have to number it. And so if we numbered it the first way we did it, we would have a 3-methyl for our first methyl group coming off. If we number it the second way, where we had 1 and then 2, we would have a 2-methyl. So this would be a 3-methyl. If we went this way, we'd have a 3, and then we'd have a 6. But if we go the other way, we would have a 2 and a 1, 2, 3, 4, 5, and a 5-methyl. So we can have, our numbers could be a 3, 6 or a 2, 5. All right. And the key is the first number. We want the smallest number possible, but if we're looking at the first number. Now, if the first number is a tie, then you go to the second number. All right. But since 2 is smaller than the 3, then we don't have to go to the 5 and the 6. That will tell us that we are going the way where we have a 2 and then, of course, a 5-methyl. So this is a 2, 5 dimethyl 4-heptanone. All right, and then the last one for today we're going to do is the last one in 2363, which is CH3, CH, CH3. Now you have a C, triple bond, C, and CH3. Now be aware that on the test, this may look like this. CH3 sub 2, CH, C, C, CH3. All right, so you have to be able to go from this, and you will want to practice that, be able to go from that into the structure you have on the left. So we recognize that we have a triple bond. That is an alkyne. All right, longest carbon chain, lowest number for the start of the triple bond. So you always start numbering at the end closest to the triple bond. 5 is our longest carbon chain. That is a pentane, but it's an alkyne. So it's not a pentane, it's a pentyne. The lowest number for the start of the triple bond is a 2. Off of carbon 4, we have a methyl. So this is a 4-methyl 2-pentyne. All right.